We all know how to find the area of a trapezoid, right? If not, the area of a trapezoid is given by 1/2 times its height times by the sum of its two bases, b1 and b2. But why does it work? So the standard explanation is to divide the trapezoid into two triangles and then add up the areas of those two triangles and then factor out the 1/2 and the h. But I actually think about it in a slightly different way that I think is much more interesting. So the area of a trapezoid is essentially the average of these two rectangular areas, where one rectangle has a length of b1 and the other rectangle has a length of b2. And of course, they both have the same height, h. So you can see that after adding b1h and b2h and dividing by 2, you get the standard formula for the area of a trapezoid. But this is just essentially saying that the average of those two rectangular areas is the area of the corresponding trapezoid. I think that's a pretty neat way of thinking about the area of a trapezoid because it also has connections to later topics in calculus, like for example, the rectangular approximation methods that students usually learn. Recall that you can use rectangles to approximate the area under a curve, and in particular, if you use left rectangles versus right rectangles, you can get different approximations for the area under that curve. What's interesting is that if you take the average of the values from the left rectangular approximation method and the right rectangular approximation method, you get the value obtained from the trapezoidal rule. And the reason why this is true is due to what we talked about earlier about how the area of a trapezoid is simply the average of those two rectangular areas. I just think that's a really slick way of thinking about the area of a trapezoid, but do y'all know of any other ways of deriving the formula for the area of a trapezoid? Let me know. All right, with that, I hope you're doing well. Make sure to hit that follow button for more math content. I would greatly appreciate it. And as always, I'll catch y'all in the next one. Take care.